I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 12. We are in our hot and cold unit. Cheryl, what's your question this week?
Well, Ryan, last week when we started this unit, you were sharing with me about molecules moving at different speeds when they're hotter or colder and what even is temperature and all that stuff. And we got it. Nailed that. Yeah, I'm pretty sure I got A+. I probably did. And so I've been thinking more about that as I've been cooking in my kitchen or things like that, where I can see water and liquids and I'm using heat as I'm cooking or freezing an ice cube or things like that. And there's this piece that feels like it is missing from my brain.
I don't know that I can help you if you're missing part of your brain, Cheryl. I think that's another podcast.
The part of my brain that now has this information. And we talked about dissolving before. And there's this piece that's missing that is when water boils. Why does it bubble? That's so weird. Yeah, that's my question. Why does boiling water bubble?
Why does boiling water bubble? That's a great question. I think that's a really good example of a relatively common everyday thing that I don't know that we think about all that often.
Yeah, well, and it feels different in that you don't need to convince me that boiling water bubbles. You don't need to convince a child even that boiling water bubbles. I'm like, cool, yes, it bubbles. We all know that to be true. But I'm like, I don't know why that's true.
Yeah. Okay, perfect. Why does boiling water bubble?
Yep.
Well, we'll dive into the pre-assessment. And let's start. I'm actually going to focus in a little bit first, and then we can broaden out a little bit more.
Okay.
What do you think the bubbles are made of?
Air.
Okay.
I think they're the same as just the air outside of the water.
Okay.
That makes me think they're not by the fact that you asked that question, though.
No, I mean, if we want to understand the bubbles, we have to understand why they're there. We have to understand what they are too.
Yeah.
Right? So I'm just trying to pick at information.
Wait, but they come from the bottom.
Okay.
They come from so if I think about a pan and looking in a pan with water boiling in it, they develop from the bottom and they move upward.
Okay.
So if they come from the bottom, it must be the air in the water.
Okay.
H2O. Is it O, oxygen? Is the molecule falling apart? And is it just the oxygen that's left? Wait, what's hydrogen made of? Well, hydrogen, but is it both the H and the O? But yeah, I'm stumped as far as that line of thinking goes. But it does come from the bottom of the pan and it goes upward.
Okay. That's good. What else have you noticed about the bubbles? One, you mentioned that they start at the bottom. Anything else that you've noticed about the bubbles during the boiling process at all?
Well, I like rolling boils a lot because things get a little crazy and splashy even sometimes. But the water's really moving. So the more there's the boil, the higher it's boiling, the more the water's moving.
Okay.
Which, I mean, we did talk about that last week, that the more movement, the higher the heat. So that feels like those molecules are moving a ton when they're really hot and dancing around. So then it makes sense why it's moving a lot, but like more like visibly moving as opposed to like your example of when you put the food coloring in the water, you can see that they're moving, or like you
Mhm.
can you can see that the water is moving, but it still doesn't make sense to me why there's bubbles in it then.
Okay.
That feels like, how is that even related to the molecules moving really quickly?
Okay, so you understand the molecules moving quickly,
Mhm.
but the bubbles don't seem connected to that at all is what you're saying.
Yeah, and I used to think, well, the bubbles are what's making the water move. Like in a rolling boil, it's rolling because there's bubbles coming up. Like in a jacuzzi when you like turn on the jets, or something like that. But now I'm wondering, like, is part of why it's moving just because the molecules are moving quickly, even if there weren't bubbles being like forced through the water? Yeah. Um well, and obviously it gets so hot that steam comes off the top, so eventually it just becomes a gas.
Okay. So what becomes hot that it becomes a gas?
The water
Okay.
turns
And so
into a gas because
which
it
is
becomes
steam.
hot enough, which is the steam.
Is there always steam coming off of the top of boiling water?
I think so.
Okay.
Doesn't there have to be? Unless the room was the temperature as well, then like, well, no, because then it would all be gas if the room was that temperature of the steam. It would evaporate very quickly. Eventually. I'm trying to think
Okay.
of an exception. I think there's always steam.
Okay.
Unless there's a lid on it, but then the steam is still there. It's just not like traveling around the room.
Mhm.
It's just like consolidated under that lid. Wait, is it a gas? Or is it tiny droplets of water that are very warm? Now, I'm not sure. I think it's a gas. Everything becomes a gas eventually if it gets hot enough.
Why are you second guessing yourself?
Because you're asking me questions. And it's making me feel like, oh, maybe I'm wrong. And because it's moist. So then is it just tiny droplets of water if it's moist? Steam.
Okay.
Like it like fogs up your glasses and stuff. It's
Uh-huh.
very moist. Yeah.
I think that's a lot to go on. You've got a lot of ideas and you're already doing some really good thinking with it. So I think we're good for the pre-assessment.
Love it.
Well, Cheryl, based on your information in the pre-assessment, you, as always, have a great beginning understanding that I can build on.
Yay.
Let's start with what you were talking about, where you were talking about where the bubbles come from.
Mm-hmm.
You said that you saw them coming from the bottom of the pot or the pan.
Yes.
Why do you think they come from the bottom?
Because they're related to the heat source, maybe?
Okay, because where's the heat source?
On the bottom, unless, I don't know, you're in like a convection oven or something, and then all bets are off. But
Then all bets are off.
yeah.
Right. But typically you don't boil water in an oven. You can, and there are
Correct.
certain instances when you would, but
Yeah.
in general, that's not typically what you do,
Mhm.
right?
Yeah.
You're usually going to do it on a stovetop. And you're right, the heat source is on the bottom. So remember to last week, we talked about, and you mentioned this already, the hotter a substance is, the faster its molecules are moving,
Mm-hmm. Yes.
right? So where in, if you had a pot of water, where in that pot, as you're heating it, would you have the fastest moving molecules?
Closest to the heat, where it's
Close,
the hottest.
which is where on the pot?
On the bottom.
On the bottom. Flip side, where would you have the slowest moving molecules?
On the top.
The farthest away from the heat source,
Mm-hmm.
right? So far, this is in line, I think, with what you were saying and what you were describing. So the
Yeah.
bubbles start to form on the bottom because that's where the molecules start moving the fastest because they're the closest to the heat.
Okay.
Tracking so far?
Yeah, that makes
Okay.
sense.
Then I asked you, what did you think the bubbles were made of?
And I had a couple answers.
You did have a couple answers. And why do you think you adjusted your answers partway through?
Well, because I was realizing, like, if it comes from the bottom, how are you suddenly getting what's in the air in solid water? So then it
Or
made me think
liquid
it
water,
was
but
something
sorry, we're talking about phases here. So
in pure water.
okay.
In strictly water.
Oh, sure.
Like, how would the air get down there if it's starting from the bottom? So
Yeah.
then that made me think, well, then it must be something that's happening to the water molecules that is producing a bubble, as opposed to like space between the water where the air
Yep.
is coming through.
Yep. And all of that is correct. I'm going to say something that I think will make sense to you, but you may or may not have thought of before.
Okay.
In common everyday, I don't even know if it's language or just conception around things, the way we think of these ideas, we typically use the word air to describe anything that's a gas.
Yes, totally. Yeah.
And I think that's what you're doing here. Scientifically, that is not always the case. The air is the specific mix of gases that's in our atmosphere, which is almost entirely nitrogen with a little bit of carbon dioxide and oxygen and a few other trace things thrown in there, but it's mostly nitrogen. So when we talk about if something is filled with air, that's a very different statement than if there is a particular substance that is a gas.
Yeah, that makes sense.
Okay. And that's what's happening when water's boiling. Because the issue that you noticed is true. There's really no way for air to get through the water to the bottom to then work its way back up again.
Yeah, totally.
So what's the only thing that's in the pot at the bottom?
H2O.
Exactly. Water. Got a couple of little water molecules here.
Okay, this is the point in the episode where I point out, listeners, if you are listening to our podcast, you can also check this out on YouTube and see Ryan's amazing visuals that he has every episode. It's always a surprise. And right now, Ryan just produced 2 little H2O molecules.
I actually have 2 more too.
Oh,
like 4 of them. But
that look like they belong in a circus being juggled, perhaps.
Yes. So you've got these water molecules, and as they heat up, they go through something called a phase change.
Ooh.
I don't think we talked about phase changes last week, did we?
Not last week, but I feel like it was touched on during the dissolving episode, because we were talking about, like, does it actually change what it is, or is it just separated?
Okay. In science, when we talk about a phase change, like within the dissolving, that's something like melting, boiling, freezing. Those are words you're familiar with, right?
Yeah, but melting can be similar to boiling and freezing. I thought melting was like its own deal.
So let's go to the visual, shall we?
Let's do it.
Do you remember seeing this sort of a model? I think actually I had it as water molecules before.
Yes.
Do you remember seeing this model?
Yes, I do.
Okay.
It is like some sort of a vat.
That's a good word for it.
And it has like a bike pump on the side of it.
Uh-huh.
And then we have like a pressure gauge and a thermometer. Oh, it's way smaller than I thought, because I just noticed the finger on the top of it.
Yep.
And right now you chose water as the molecule to be inside of the vat.
Yep. And look, the little water molecules on the simulation look the same as my little models that I have in person.
And they're even red and white. It's so fun.
Exactly. So we're not going to worry about the bicycle pump or any of those sorts of things. But at the bottom, underneath it, you can add heat or a source of cool that'll pull heat out. Right now, this is in the solid phase.
So where they're just like kind of moving around, but not much.
Exactly. So you've got the water molecules. They're more or less sort of locked in place compared to each other, but they're still moving. So they still have some temperature.
And it's in the
As
shape of an ice cube.
it's sure. I'm going to add heat and I want you to notice what happens.
Oh, the ice cube melted. They
The
went
ice cube
flatter
melted.
and closer together.
Yep.
But now also there's more movement. They're starting to like dance a little
Yep.
bit more.
They're moving more and they're not locked in place with each other anymore.
Popcorn's popping.
What did you just see?
It looked like popcorn in the oven, or one like all of a sudden like flew up in the air.
So one of the little water molecules disconnected from all the rest and went up above where the rest of them are, and then it came back down again.
Yeah.
Yep. So that one water molecule had slightly more energy than the other ones around it. And so it actually went, oh, and there was another one. It actually became a gas ever so for just a moment. So every time you go from one, what we call phase, like a solid to a liquid, that's a phase change. Solid to liquid is what we call melting. Think of like an ice cube, right? When an ice cube melts, it goes from a solid into a liquid.
Oh.
Does that make sense?
Yes.
So in science, we call each of those phases of matter. So the solid phase, the liquid phase, or the gas phase. And as you add more energy to a substance, you can get it to go through a phase change from one of those phases to another. And so if I continue to heat up this that's in the liquid phase right now, you're going to notice more and more of those water molecules are going to start jumping off the top there, and they're going to have more and more energy.
That's a rolling boil.
It's getting really close to a boil. Okay. And you'll notice now that they're separate from each other. They're not even really next to each other, most of them anymore. And this is not a perfect simulation.
Now it reminds me, I don't know if you've ever seen one of those little things that like a person goes in this very small enclosed space and they put a bunch of money in it, and then like a fan blows and you try to collect all the money. That's what this feels like.
Yep.
But instead of money, it's water molecules.
Yes. So these water molecules are now in a gas. So we went from a liquid phase to a gas phase. When you have a gas inside of a liquid, it's a
bubbles.
Bubble. Yep. That's what a bubble is.
Oh.
So the bubbles in boiling water are the water molecules that are near the bottom. So they're getting the most heat, and they've gained enough energy to go through a phase change, to go from a liquid to a gas. And that phase change we call boiling.
And then we call it steam.
Well, we'll get to steam in a minute.
Okay. When the finger on top of there like lifts off the lid and then it goes steam. So this is boiling.
This is a gas is what it is what you're looking at.
Okay.
So boiling is when you have a liquid and it reaches the boiling point, the boiling temperature, which is 212 degrees Fahrenheit, or in the superior system, 100 degrees Celsius. That is the boiling temperature of water at standard atmosphere and pressure. But
cool.
Does that sort of make sense?
Yeah.
So that's what the bubbles are made of. They're just made of water. It's just not in a liquid phase anymore. It's in a gas phase. And when enough of it.
So cool.
Yeah. And that's why if you think about it, when you watch a pot starting to boil, you'll notice a bunch of little tiny bubbles first.
Yes.
And then the bubbles will get bigger and bigger and bigger and bigger. That's because more and more molecules are turning into a gas. And once enough of them get there, the gas is buoyant enough, which is a whole nother idea, but think of it as being light enough. It's more complicated than that, but that it can actually detach from the bottom and float up through the water up to the top, where it releases into the rest of the air.
That's so cool.
Does that make sense?
Yes, it totally does.
Okay. Then that leads to the idea of a rolling boil that you were talking about.
Yes.
Right? Where you were talking about, well, if there's more water and the molecules are moving faster. And what you used to think was that it was just the bubbles that were doing it.
Yeah.
Well, your old self was correct.
Really? It's just okay. Great.
It is. It's the bubbles. And the reason that it's different from like as it goes on and it's boiling more and more. The reason it's different is because you have more and more of those molecules that are going through a phase change, that are turning into a gas. And as those bubbles are moving through the water, they're pushing the liquid water out of the way. And so the more of those that there are, the more of the surface gets all turbulent because bubbles are moving through it all the time. And so, yes, the water molecules themselves are moving faster, but the molecules are so small compared to a pot of water that you wouldn't really see their motion.
Okay.
Does that make sense?
Yes. Yeah, it totally does. Yeah.
So you should have trusted your gut.
Depends.
Cheryl, just follow your heart.
Ooh, no. I'm going to tell your students that you said that. I'm going to get you in trouble.
So the last piece is the one you were just mentioning, which is steam.
Steam.
And it's very interesting because you talked about steam being a gas, and that's when it's hot enough. And then at the very end, you had a new idea. What was your new idea at the end?
Well, it was that maybe it's just tiny little water droplets in the air.
And what made you think that?
Because it's how steam feels. It feels really moist. So then it feels like there's still some moisture or liquid in it, that it's not just a gas. And like I don't know, when I open the dishwasher and feel it on my face, like my face is wet, after that. So yeah, then it made me feel like, oh, maybe it's more like a humidifier or something like that, where it's actually just tiny, tiny little bits of water that are floating.
And you are correct, Cheryl.
Oh, really?
Yes, it's another common misconception. People talk about water vapor, which is the gas phase of water, and steam as interchangeable. And they're not really. When water is truly in the gas phase, you can't see it.
Because it's air.
Exactly.
Quotes,
like right now, in the air around us, there is water vapor.
Yeah.
But we can't see it.
So that's more like humidity. Like in a more humid climate, there's more water vapor in the air?
Yes.
Okay.
Yes.
And you can't see it. You feel it.
You can feel it for a whole host of reasons. And we could talk about that too at some point if you want to talk about what humidity is and why it feels disgusting and all of those things.
And why my towel doesn't dry overnight when I hang it up at Disney World.
Yep. You could write that down if you want to. We can talk about that. That could be your question if you want.
Love it.
Since you can see steam, you are exactly right. They are little tiny, they're not single molecules of water, but tiny droplets of water. So it's water that turned into a gas and started, floating up away from your pot. But as it got farther away from that source of heat, it cooled down enough to turn back into a liquid. It went through a phase change again, and it condensed. That's the name of that phase change, from a gas to a liquid.
Okay.
Is condensing.
That's so interesting.
Yeah. That's also why a steam burn can be so much worse than just like hot. Like, think about it. You can put your hand in an oven that's 400 degrees and your hand isn't all burned, but you can get burned by steam. Steam is only 212 degrees. And yet you get way worse burns because it's liquid. And that's a whole nother thing, is why can a liquid burn you more than a gas? And we can talk about that at some point too, if you want to, but there you go.
Love it. That's so cool.
All right, Cheryl, time for the quiz.
Oh, excuse me,
Mr.
Palmer. I think I need to use the bathroom, actually. So I'm just going to skip this section. I'll be back soon, though.
I mean, that's fine if you just want a 0.
Ooh, nope. I don't want a 0 though.
So you'll stay for the quiz then?
Yes, fine.
Okay. You always do fine. First question. Why do bubbles start to form at the bottom of a pot when it's boiling?
Because that is where it's closest to the heat source, and the bubbles are water in their gas form, and gas happens when it is heated up more.
Great. What are the bubbles in boiling water made of?
Water.
Bingo. Look at that. You're 2 for 2. This one will take a little longer. Describe what happens to the molecules when heating a pot of water to boiling.
They start moving
Okay.
more and more because of everything we talked about last week. So see last week's episode for the rest of that. And then also eventually they briefly turn to gas. And then also like eventually permanently turn to gas. And so that causes like little bubbles at first, as there's like tiny little amounts of gas. And then eventually those bubbles like stay bubbles all the way to the surface because it's hot enough. And then all of a sudden there's lots of big bubbles pushing the rest of the water all around, flying everywhere, splashing on my burner, and sometimes splashing my toes when I'm not careful.
Ew.
Yeah, don't do that.
And what's happening to the molecules during those parts?
They're moving.
Okay.
Do you want more of a complete answer than that, though?
Yeah, like how are they moving?
Well, around. They're popping like popcorn. They are flying in the air and they're dancing around. At first, they just kind of like jiggle, but like kind of in place, and then they're just going every which way as they get hotter and hotter. Does that count?
Sure, that works. What is a phase change? And can you give an example of one?
My example is melting.
Okay.
But the phase change is when it changes from either a solid to a liquid, from a liquid to a gas, or vice versa in the other direction as well. The melting would be when it goes in the warmer direction.
Between which two phases?
Oh, I thought it could be any of them. Is it just from solid to liquid that it's considered melting? I guess that makes sense. That's how I would use it. Okay.
Yep, because you can skip that. You can go from a solid straight to a gas, but that's a separate process.
Oh, wow. Wow, okay.
And if you want to talk about that, we can talk about that another time. Last question. What is steam? And how do you know, or what evidence do you have that steam is what you claim it is?
Steam is made of water in the liquid form. I mean, you could probably have other forms of steam than water, I'm guessing. Just any liquid could probably be steam, perhaps. But we're talking about steam from water. But it's still a liquid. It's just tiny, tiny little molecules separated from each other more than when it's in the pot. And they're flying through the air, but they're still in liquid form. They're not a gas. And a good way to tell is if you can see it, or I was going to say if you could feel it. No, you can feel the moisture in the gas too, but you can feel it extra. And if it leaves a liquidy residue on your skin or on your counter or on the lid of your pot, that would be a good way to tell.
Yep. And you started to say one that you then moved a different direction at the very beginning. You could see it.
Yeah. Did I not say that? I thought I said
you did, but then you didn't finish the thought and you moved the direction.
You can see it.
Oh, okay. Great answer. You passed.
This is how you do it in class too, right? You're like, I think you started to say it.
Yeah, exactly like that. That's it. You got it. That's all the time we have this week. So why don't you go ahead and start packing up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.